Hello and welcome to Construction Tech, presented by House Accelerator, a catalyst of zero carbon building. We're happy you're here. We welcome all comers to our exploration of how to slash the greenhouse gas emissions of our buildings and make them more resilient to the extreme temperatures, wild weather, and grid insecurity caused by climate change. With our co-hosts, Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce this weekly series to dive into the details of Passive House construction practice, with a technical focus on technique and technology in the field. New to all of this, please visit the Passive House 101 section of our website to get started. With that, please enjoy Construction Tech and pose your questions in chat for the discussion session following the presentation. Thank you. Alrighty, welcome everybody, and we're super excited to have James Hartford back to present. He was, I think, on the showcase last time, and we're super excited to have him back with the Accelerator at tonight's Construction Tech to present about building passive house during supply and labor shortages, alternative building systems. So with that, I'll hand it off to the co-host. Thank you.
Hey everybody, a little mix up there, but that's all good. Welcome everybody to another event. Now, originally when James was on the happy hour, we thought we'd all get together for Halloween. Well, we're not able to do that, and so we might as well have him back talking about our really cool projects and what he's up to. So if you're, or as you're watching this show, I just wanted you to just think about is how can you include passive house in your projects? How can you include some other things that are outside the box? Because James is going to show a lot of different things outside the box. Shannon, over to you.
Thanks, Sean, and thanks for jumping in for me there. I had a moment, so I appreciate the help. Good evening, friends. If you're new here, welcome. I'm Shannon from Sanderson Design, zooming in from New Hope, PA on the East Coast. And you're about to see a great presentation tonight, a number of buildings from a number of different approaches. And you're also going to get the friendly challenge. So I'm excited for tonight. If you have a question, put it into the chat with Q, and we'll save those for the end, and we'll let you ask them in person. So buckle up. Kevin, over to you.
Hey, Kevin, can I interrupt for a second?
Of course, Mark.
Hey, Shannon, I'm here with Travis.
Hello.
We're at the
Midwest Building Science Symposium, second annual at Boulevard Brewery in Kansas City, Missouri. How are things at Passive House Accelerator?
You guys are here.
We wish you were here. We're still drinking beer, though. Come on over.
We started at 8 o'clock this morning. Some of us met at 7 o'clock this morning for breakfast. I apologize for not being live tonight. I'm with Travis, I'm with Joe, Catalyst, and about 250 building science people. I can't wait for the presentation tonight. Bless your hearts. Over to you, Kevin.
I'm thoroughly jealous that you guys are at a brewery right now talking building science with the minds of Passive House. I saw some Instagram posts. I'm very jealous, but you all shouldn't be too jealous because we have a great presentation for you tonight with James Hartford. I'm Kevin Brennan from New York City. James Hartford is right up the river in the Hudson Valley. I've admired his work from a distance for many years now, and I've watched him grow the Passive House community in the Hudson Valley. And with great admonishment and the work that they've created in Chasing Passive House, I'm excited to look at what James is doing, diving into the details of work and the constructability of Passive House. And he's going to share his story of his work over the past few years and get into how to build Passive House in 2021-22. So James, the screen is yours, the presentation. Thank you.
Great. Thanks for having me here tonight. I'm really excited. I've got a lot of images, so I'm going to kind of rock it through. So, hopefully I'll make it. Wish me luck. So we've got a small team here. We've got 6 architects, 4 of us are CPHCs. The firm was founded by Juhi and I back in 2003, and we've been kind of engrossed in building science from the get-go. We are based in the Hudson, right along the Hudson River, just like Kevin had said. in this little town that's nestled in the Hudson Highlands. Cold Spring is 1 square mile, and we've got 3 certified passive houses built in that 1 square mile. Our projects range in scale from large multifamily new construction, winner of the Buildings of Excellence by NYSERDA first round, to additions and new constructions, and everything is pretty much passive house, or on the spectrum at least. So here's a little backyard studio that we did sort of as a precursor for panelized construction, something we're trying to get into. And also using helical piles, so it's really kind of floating lightly on the landscape. We participated in the Energy Sprung Retrofit New York pilot program, and I got to go to Holland and see how they're doing it there. It was really exciting to both see the projects being done at really large scale, as well as going to the factories and seeing just like incredible things that are, we're just dreaming about here. Our firm is fully hands-on in the technical. We do our own WUFI passive modeling. We used to do PHPP back in the day, but now we're fully WUFI. And we also do all our own therm work too. And we use these as design tools so that we can get the right balance, knowing how big of a window we can have, optimizing the thickness of walls and things like that. So our first passive house was a retrofit of this sad little building. This building was, it's right on the banks here in Cold Spring, overlooking the Hudson and over to Storm King Mountain. It was flooded by Hurricane Sandy, and so we were hired by our clients. We explained passive house to her, and she said, "Why would I do it any other way?" And so we retrofitted the ground floor, which is originally a garage, and then renovated this second story, putting a trowel-on air sealer, so that we're just retaining the original siding, sheathing, I should say, and built a third story on top of it. And the builder, Ed Nugent, I saw him on earlier, shout out to Ed, he built his own trusses and came up with this approach with us. And this is the result. So we took this sad little building and made it pretty iconic. We got a lot of love with this one. It's right on a public park, so people walk right past it all the time. And views upstairs from the top, the new floor, out to the mountains is excellent. And with the solar panels on top and our energy performance, basically our client doesn't get any energy bills. This is our own building, which is back in the day. This is before. We bought this sad little blacksmith shop right on Main Street in Cold Spring. With the goal of actually lifting it and just doing a deep energy retrofit passive house. So here, I love drawing it by hand details, and these are hand sketches of the details that I came up with to expose the original timber structure and soup it up to passive house performance. You can see a few things here, like there's some cool little details where we've got foam glass creating a thermal break between the foundations and the framing, and actually came up with a way of getting foam glass all the way around the window, jambs, head and sill, so that we have thermal separation entirely. So no thermal bridges, even though it's a retrofit. We ended up actually replacing the foundations entirely because they were decrepit, and we discovered 12 cubic yards of contaminated soil from the gas station next door. So that allowed us to actually push the foundations out further so they align closer to the outside, giving us an extra foot of space in each direction in our basement, which is critical. So here's the building. We lifted it up, slid it off the foundations entirely with a house moving company, the timber frame element, replaced the foundations and clad them with the stone from the original cobblestone foundation. Brought it back and reskinned it. So we took off all that old siding and added sheathing for structural strength and 3M films for really incredible air tightness. Clad it with our Larson truss. As you can see, this is really becoming our go-to approach. And same for the roofs, so that as we go up and over, it's basically the same same shtick, so that we have really good continuity. Air sealing's really simple, no crazy ins and outs. But there's a lot of passes. There's a lot of wood in this wall. So here it is with the dense packed cellulose and the building wrap, and yet another reset of the scaffolding and the siding going on, and also recreating the original raptor tails to create that overhang and the historic look. But then what we get is like a really new, fresh outside, but we then also get to expose the cool interior, which you're also seeing in the background behind me. So we're able to bring back history that would ordinarily be encapsulated. And then we moved on to another project where just around the corner, a historic house also in the historic district burned to the ground. And so our client asked us to design a new passive house for her, but she wanted to do something different, going modular. But we didn't know of any modular companies building passive house about 5 or 6 years ago. So then we just went with a conventional modular company. We had six boxes lined up down the street. A lot of coordination goes in ahead of time because every decision is made, including tile and wall, paint finish. So the coordination is really hard. Lots and lots of detail and drawings, and lots of reviews of shop drawings and resubmittals. But then the boxes arrive, the foundation set, and then we start to swing them in. Lots of care has to be given to overhead wires and making sure that there aren't obstructions like that. And so then the boxes come in. They're set, I think we were set in 3 days. No windows installed, and it's just simple 2x4 construction with batt insulation in the cavity. So really, really simple, basically less than code built, but then we retrofit. So here we go, the same punchline. Larson trusses, field installed windows, which made the boxes much lighter and of course reduced the risk of damaging them. And there it is in its glory. So and then we started looking at other options. Here's a passive house we built with Benson Wood and R.L. Baxter. It's along the banks of the Catterskill River. And we knew we were going to be starting in the dead of winter, so we did the concrete foundations early before freezing and protected them from freezing and frost heave, and then had the panels brought in. So you can see in the tracks around the site that there's a lot of staging and site work required to prep for this. Big crane with a large boom and a lot of attention to how getting that set level and then the radius of that boom. But once the panels started going in, with the windows in, insulation systems in, we had the building entirely dried in 6 days. Some of the larger windows obviously went in later, but it's a 4,300 square foot house and airtight in a couple weeks once we got the larger windows in. Once the windows were in, we didn't even need any supplemental heat for the space. So this is a typical Benson Wood wall, 2 by 8 construction with cellulose dense pack, and then wood fiber insulation 1.5 inches thick on the outside. So it's still wood labor intensive, but the flexibility of using prefab helped us to overcome the climate conditions that we're up against. It is pretty close to finished. We have solar panels and battery storage on site for basically no requirement for a generator at all. And we have a wood burning fireplace installed too. And so this is typical Benson Wood wall with a shallow footing, but at the same time the soil conditions warranted the stem wall, so we didn't get away with going completely shallow footing. This is a little bit of a throwback. This is one of our earliest high performance buildings that we've done. It's this is a LEED silver house in the hills up from Cold Spring, and it had a HERS score of 60. So this is prior to any of my passive house training. It's would be abysmal if I came out bragging about my CPHC status and this is all I could come up with. But it was a good test of the waters. We use SIPs because it was light, minimal impact on the site, and we can set them with lulls or rough terrain forklifts, and people are able to boost them around too. These are graphite infused, and you can see the holes in there are pre-drills for wiring. It helped kind of expedite a lot of the site work. SIPs really minimize the amount of disturbance to the site. We wanted to keep as much of the nature preserved as possible. And then the panels for the roof themselves they're 12-inch thick, so pretty beefy. And those we were able to set with the rough terrain forklift as well. So that went well. The insulation is completely outboard of the steel structure. Steel structure is shop galvanized, so like really low maintenance. And this is what the house finished up as and pretty much looks like today. View from the other side out of the master bedroom. And so then moving on to our cidery project, we were approached by a client who was retiring from Chicago and moving back to where his family heralds from in the Catskills, home to a long history of cider making and a little bit of bootlegging too. So our clients asked us to help design with them a passive house because it married really well with the objectives of doing a natural organic cidery. So here's the entire team, including the architects there, learning to plant apple trees and to co-plant with plant species that help keep pests and problems away. Called Seminary Hill because that old seminary back in the background here, and it's a beautiful spot. We we used the vernacular of the traditional bank barns throughout the Hudson Valley and the Catskills, and most of them are either gone already or soon to be gone. So they're really beautiful structures and fit the landscape really beautifully. I was really inspired by how the light comes through in these spaces. They're just really beautiful. Originally, they were gapped like this so the hay would dry and not cause combustion, but there's such beautiful, enjoyable spaces to be in. So our cidery has two programs. One is apple, fermentation and storage, and then the other is for human enjoyment. And there's two different condition zones that we need to meet. So we actually have no insulation under the slab and minimal insulation in the stem walls on either side. So we're able to use the ground cooling to the advantage. We want about 55 degrees for the apple storage and the fermentation process. Upstairs, it's a different story. So we have our air tightness layer at the floor, and then a SIP timber construction here. SIP walls with trusses and loose fill insulation there. We originally were planning on using ICF for the foundation walls, but actually switched to Poraver because we were able to get just enough insulation to make it work. So we had to blast the site. It's all hard bluestone. We call it bluestone even if it's red like this. Looks like Martian land. You can see that's the Delaware River way off there in the distance. Shannon's somewhere over there waving to us. And so the Poraver foundations with some mineral wool insulation and later some foam insulation on the outside was all we needed to condition that space. And then Intello on the ceiling, I'm pointing to the wrong screen here. Intello on the ceiling and loose fill cellulose. And then galvanized steel again, just because we want to, it's a very wet process in beverage production. And then heavy timber frame construction with moment connections. So once we get those timber bents set, it's from New Energy Works. They also supplied the SIPS panels for us. And we have a zip sheathing layer as our air tightness, because the real trick with SIPs is how to maintain air tightness. And on the inside, the goal is to keep the timber exposed and per lens and to take in that view. It was brutally cold there. It's a climate zone 6, and we battled ice and snow for the entire duration of this project, it seemed. But the timber frame and being exposed really added to the character of the space, and really was fun. It's a cool way to build. So here we have the SIPs just marching around, and then the raised heel trusses, and you can see what the space is shaping up there. So a zip sheathing diaphragm would come across the underside of these trusses for air tightness. And then it's shaping up nicely, and a similar view of it at completion with the bluestone cladding at the lower level and reclaimed larch timber, which is old growth wood from the Hudson Valley that was actually used as pilings around the old Tappan Zee Bridge, which was decommissioned and removed. So these logs were pulled out. They spent 70 years sunk into the river and were pulled out and remilled and created siding for this, both inside and out. Fermentation vessels and conditioning vessels in the cidery, floor drains, all typical stuff. We've done a bunch of breweries, and this is kind of old hat for us. But what was nice is to have a really clean space that had just like what was optimized for the production, and views back out and lots of natural light. And then upstairs, the timber frame exposed, looking past the bar over to the dining area. Apple-inspired lights, and there's that peek-out window beyond the immovable table or piano. And then the kind of the throwback to that dappled light effect that I really loved in that barn. The gapped visual effect is kind of tricked. We've got polycarbonate underneath so that we've got weather protection under there. But those moments when you have kind of non-passive aspects, it's fun to kind of go a little crazy. And then, some other products that we've been looking at. Now I'm kind of rambling through and just blasting through on our portfolio, but I have to pause for a moment just to say that the impetus for all of this search is, solving different problems, weather, climate problems, concerns of clients on timeline and quality control and choosing modular. But really, one of the things that's really driving us a lot is the scarcity of different products, particularly highlighted in the age of COVID because of the disruption to supply chains and distribution. But it also gave us a time to rethink just using commodity market kind of stuff. So New York State is actually doing a lot to encourage industrial hemp production and looking for partners to actually develop building products. But that was weird. That was slow. But so we're currently designing, it's right on the boards now, a design studio where we're looking at using hemp blocks for this construction. We were asked by the client to consider straw bales, and our builder is concerned about durability with that. So we've been pushing for hemp because it's got just really great properties, including it's antimicrobial and water repellent. So it's a really cool product. The hemp blocks are made from the interior herd of the plant, to the outside is the fibrous thing that we know from rope, natural rope, but the inside is more like a little chalky thing that you can see here. So this is mixed with natural lime as a binder, and so it's got good air quality issues. It actually entrains carbon dioxide in the curing process, so it actually is carbon negative, as well as hemp is really cool in that it goes through a full growth cycle in one season. So we're able to the stock used for making any hemp product gets all of its growth done in one summer essentially, as opposed to wood or bamboo or other things that take many years to mature. So that's got an incredible capacity for carbon sequestration. I said I wasn't going to use that word because I can't say it. The outside is rendered with lime, and the cool thing about these blocks is that they stack together in a Lego kind of fashion, and then so they're dry fit, and then they're skin coated with the lime plaster as a render. So it makes a really great simple wall structure, very low technology. Really anybody can do this stuff. The question is, will we see cracks at those joints? Will we maintain air tightness? Will we get air tightness? Those are questions I still have to answer. So I'll be reporting back on that one. There are different ways to apply the hempcrete. So here you see it being sprayed or blown. Again, no toxicity to it. It's just, obviously our lungs are designed to breathe air and only air. It's funny that I'm talking about hemp in that way, but that's what it is. And so here we are, seeing a guy spraying it, and they'll skim it smooth, and then that gets a lime render as well to finish it. That can be applied inside and out. And then using the wood fiber, they make bats that can be tightly fitted into the joists, into the framing bays, and can be cut with saws and other conventional tools. So it's really easily manipulable, and you can get it to fit very accurately where we need it. It's got the bats have a comparable R value to cellulose. The blocks a little bit less, 2.5 R per inch. So we've got some really good data that we can work with in terms of substituting and fitting these into our alternative wall systems as we explore them. Costs are pretty good. It's have to kind of pencil it out to what that will cost, but it's not exorbitant. I would say it's in line with Rockwool and other products. And so then as we're working through really this big boom time, everybody's incredibly busy. It's really hard to get contractors onto job sites, especially in some of these much more rural communities that we're working in. So getting builders to bid on projects at all is a challenge, and getting people with passive house experience is really just kind of beyond the pale for some of these more remote locations. So we're looking at both further into modular construction, but also SIP panels, but not just any SIP panels, MgO SIP panels, magnesium oxide, so that these are naturally rot resistant and fire resistant. We have a lot of concerns in both in terms of increased rain events and mold growth, but also the risks of fire as the climate gets weirder and weirder. So we have several clients who have homes in the woods, planning to build on hillsides and things like that. So we're looking at fireproof construction opportunities. And so MgO boards are what we're looking at for these projects. Also reducing the amount of concrete, so doing a structural edge, shallow concrete footing, and likely gravel insulation underneath, and MgO boards. So MgO boards, if you're not familiar with them, it's a similar feeling to like a cement board, but it's not as brittle, very, very durable, and high fire resistance. These also sequester CO2 as they go through the curing process. And they come just like any other SIP, flat pack, pre-cut, and ready to go. And the goal is to build a beautiful house with this. The great thing about the MgO boards is they can also be used for interior sheathing as well. Again, zero mold growth with these products. And we've got, last on our list here, is a project that just broke ground in Cooperstown, New York. Shout out to Josh Edmonds and Simple Integrity. We're building a 12-unit multifamily passive house, market rate. And we're clocking in at $185 a square foot in today's prices. So we're really excited about that. Our wall sections are kind of similar to the Bensonwood model, but we're using 2x6 with dense packed cellulose, shallow J footings, frost protected, and then 5.5 inches of rock wool insulation to the exterior. So it's a super cost-effective strategy. We're switching away from our usual the insulated I-joist strategy to that raised heel truss because it's just easier. And we're excited to have this project in the offing. That's it. So that was 86 slides. How did I do that?
Wow. Awesome.
Incredible. I will be making no honking sounds at all. James, that was fantastic. I lost track of how many projects you showed us.
Yeah, I completely agree. Again, you went through the whole plethora of different material choices. So it's really great to see. And I know we've got lots of questions like, where do we get this stuff? Who's your contacts? All this stuff. So we'll dive into it.
Cool.
I don't know which one I love more: the fact that you're building fireproof construction in the Northeast and really giving an emphasis to it, or the fact that you love cellulose even more, which I'm a big fan of. So I'll let the questions roll through.
I would love to see. So my challenge to the SIP manufacturers is to get together with those hempcrete people and make a SIP using like low embodied energy sequestering materials like that. So we can get off of fossil fuel products entirely.
It can happen. We create the demand, we create the projects, we create excellence, and everything will follow.
Exactly.
And people like you and your beautiful designs. I mean, every one of those projects could be Main Street USA, and the designs there. I mean, I want to go have a cider at that cidery and just be in that space, especially that indoor outdoor space that looks like a barn. It's absolutely beautiful. You do a great job.
Thank you.
Yeah, but I think there's a future construction tech that we're gonna have from that barn.
And we're gonna sip talking about sips.
I'll sip to that.
I do love a good hard cider, and I really like the way that you use the temperature of the earth for the apples. Pretty cool. And I really appreciated the way you saved a lot of original buildings in communities. A lot of those, I could see people just knocking them down, and you saved them, even that office that you're in, which is beautiful.
Thanks.
So my favorite was the Tappan Zee Bridge wood. Pretty awesome. And learning more about the benefits of hemp. There were some things I knew, but there was a lot I didn't know. So really appreciate that. I think
Shannon, can I jump in with a brainstorm?
Yeah, sure.
So Mark's at a building science symposium in Kansas City at a brewery. And I think we might need an East Coast building science symposium at a cidery, maybe. That's actually a passive house. I'm just planting seeds here, hopefully. But
some good apple seeds, my friend. Good work.
Okay. I could pick that.
Yeah, Barbara wants to know how far it is from Terrytown, which is where we're all going to be pretty soon. So
yeah, unfortunately, we tried really hard to make it land, and to actually do a pre-conference workshop. So everyone knows Terrytown is where the FIAS North American conference is going to be held this year. Really excited. In a lot of ways, I can't say that I'm co-host to that, but the organization that I helped found is the Passive House Alliance Hudson Valley chapter, which is kind of this large, thriving group, and we helped make it happen here. So we're really excited for that and to kind of own that. So, but to answer Barbara's question, unfortunately, it's a little bit too far, and it's about an hour and 45. No, it's about 2.5 hours from Terrytown to get there. So a little bit too far to make it work in both the tours or the pre-conference. But I would love to have a construction tech field visit.
Yeah, I think I could make it.
Count me in too.
Yep. Well, why don't we go over to Michael Ingui? I think he has a question for you to kick us off.
Thanks. Thank you. And James, cheers, first of all. One of the things that I love about your work is not only does it perform well, but every one of those, they are beautiful projects. And at the end of the day, we always have to kind of remind ourselves, our clients, they're looking for great looking buildings and great performing buildings. And I think in that order. And if you can achieve both, I think you've got it. So my question is, because you have a lot of people who are new to this and a lot of people looking to get into it. A lot of people kind of maybe more afraid to kind of jump in, and you've been there. So as a builder or an architect kind of coming into it, especially kind of someone who might be in a design-centric firm, any recommendations that you'd, first step, second step, kind of thing?
So and Michael, I think also that question coming from you, because it's like right back at you. You do a lot of beautiful work, and it's all beautiful work. And the thing that I would say that's really important is that we design and we build buildings that people love, because those are the ones that will last, like this building, 150 years. If people hate it, if people have to, just, we build the perfect, thermal envelope, and then somebody decides that they actually want to have a window in their house, then they start cutting holes and, design that from the beginning. So it's like, make them beautiful as beautiful as any Victorian house that's, complete, or, Farnsworth house, or whatever flavor you want. But know your building science, know how to design properly, so that you're not chasing after your own tail, trying to heat, cool, kind of contaminate a space that wasn't done well.
I would like to add something in terms of, can you hear me?
Yeah, Eddie, go ahead. Go ahead.
Yeah.
I usually keep everybody in order, but it sounds like you're adding on to Michael's statement. So.
Oh, no. In terms of, he was talking about some of the buildings that, in terms of fires and stuff like that. And I just finished a passive house, and there was a fire that burned like 40 structures. And it burned the house from the front neighbor and the back neighbor, but our passive house stood, nothing happened to it. Like, not even, it was amazing. Like, and then the air sealing, not even smoke got into the windows, like into the space. So we were like, it really works. The technology really works, or the systems really work, as long as you put them together, then they do perform, it was pretty cool.
That's
Eddie, I
a
think
great
again,
share.
Yeah, thanks for sharing. Because and you know what, you sign yourself up for construction tech, my friend, because I want to learn more about your project. So
yeah,
we'll put you in the queue.
Okay.
Absolutely. And Eddie, thank you for sharing that, especially for the people who are new on here tonight, because there's a lot of benefits that aren't part of the certification that you get when you build a passive house. So thanks for that.
Exactly. And then I work for Carmel Building and Design, which I'm a site supervisor for them, but I'm also a general contractor. And I've built many houses, conventional houses, but it's weird when you walk into a passive house, the feeling of setting it at 70, 75 degrees, coming back, and it's the same temperature, or a degree plus or minus. It's amazing, Yeah,
it does feel different. That's one of Sean and Mark's favorite phrases, is feel it. You got to feel it. It's
it's
an
just
immediate
weird.
sensation.
Yeah. So I'm pretty thrilled to build in that one, and then in a couple of months I'll start another one, and yeah. So,
thanks, Eddie. Well, I better
Thanks,
get
Eddie.
on to my list of questions here before I get too out of order.
Sorry.
So
Okay.
hang tight, and we'll talk more about that during the after hour. So our first question up is from Mo. Mo, are you out there, and would you like to unmute?
Yes, thank you. My question was related to water wells. I'm not sure if those projects, they looked like in remote places. I'm not sure if that's the case or not. If that is the case, was there well pump energy consumption calculated? Thank you.
Great, thanks. So let's see, it's a mix. We've got most of our projects actually have public water, but certainly, yeah, some the more remote ones, rural ones, do have wells. I haven't even thought about well power in a long time, and I believe that's just factored in as a necessary evil. I'm sure it's calculated into the energy consumption, but it's been a long time since I've looked at that in a model. So there's probably somebody else on here that could answer that question better.
Thanks so much, Mo. And we have a follow-up from Reed Rollins, which is also about the well. Reed, would you like to come on?
Sure. So you don't know the energy consumption of your pumps, but do you know were they variable speed or any models that you researched and decided to pick because it was efficient?
Whoa, see that now those are really good questions that we weren't thinking about, and I'm sure that we have factors in there, but I can't say that we specified them with particular performance in mind. These are good questions.
I was surprised at the depth of those immediate questions too, and I never calculated the pumps on my last project either, so I'm with you. We also have a question from Eric Rampton. Eric, are you
Hi.
there?
Yes. Hi. I think I may have misunderstood how you were using the hemp blocks. Could you explain that again? And if they're in the same application range for load bearing as something like Faswall, which does use a little concrete, could you comment then on the relative life cycle analysis of both of them? Because transportation does matter.
So as far as the hempcrete walls, the blocks that we're currently looking at, they are unfortunately made in Europe. They're handled by a manufacturer and a distributor who's based in Australia, but he's looking to bring that production to the United States, recognizing the demand that's going here. So while we may be importing blocks from Europe initially, we do have to demonstrate a need for them in a market. So there will be a few kind of hits on the energy consumption right off, but it's not a big deal. I mean, people have modeled out the carbon impact of shipping versus trucking all over North America, and it actually pencils out pretty favorably, at least to the East Coast coming from Europe. But yeah, that's the carbon impact of shipment is important there. In the example that I had shown that we're developing, we're having a structural frame inside of the hemp block walls, so they're non-load bearing. Now the hemp block does have a system of integrating structural reinforcement and concrete. They are actually pretty small concrete posts that get incorporated into the kind of cast in place framing in the order of about 4 inches or so, so much smaller than you would conventionally see in reinforced in concrete. But yeah, there are structural kind of methodologies to make those walls also load bearing.
Thanks. That was great explanation. Appreciate that.
Thanks, Eric. And we have a question from Todd Collins. Todd, would you like to come on and ask your question?
Yeah. There we go.
Hi.
No, I was just asking about the structural capability of the hemp box. They look pretty fascinating.
Yeah. So there again, it's primarily used as a non-structural application, but they make they have profiles that basically take you can load in rebar and pour concrete for headers and for post conditions. But you can also just do it as a separate timber frame and do it as a set kind of approach to the outside. So an IP, insulating panel, non-structural.
It looks a lot. It looks a lot like you could do it. You could use them the same way that you use AAC block, in that you can put in the rebar, you can do the precast headers or so, but your structure of the building is going to be something different.
I think it's important to tell everybody what AAC is.
Autoconcave concrete, aerated concrete blocks.
That's correct. Yeah.
Thank you.
Thought it was important to share.
Thanks, Todd.
I talk in acronyms. Sorry. It's the Passive House nerd knowledge. I should have glasses on, like, nerd.
Well, it is now that time in the evening where we typically ask our presenter to share with us someone who helped them along their way. And I think you may have become a lot of people's mentors tonight, James. So maybe you can share with us who got you started or who inspires you?
Oh, that's wow. And I wish I thought more about this. That was part of my homework. As a teacher, I forgot. But there are so many giants, so many shoulders that we stand on. We've got, Adam Cohen is, of course, a huge inspiration and friend. Katrin, Prudence, there are so many great people who do great, meaningful work, and I thank them all. But I also thank the clients who take the risk in trying something new and pushing the envelope and helping us explore areas that that allow growth. Because if we don't take risks, we can't fly. So this is the only way to do it.
I am really glad we're recording this because I think I need to hear that again. Thank you. That was excellent. We have a couple more questions that we can keep going on, but I want to give Kevin a chance and Mark and Sean a chance to respond a little more if they want to before we head into the after hour.
Just seeing if Mark wanted to come on, but I think he went off to have beers with the rest of the fun group there in Kansas. So we'll have to catch up to him next week of what he learned at the Midwest Symposium. So at some point we'll get him.
Is that Mark Anson you're looking for, or some other Mark?
No, Mark Anson. That was Mark Wiley. But
okay,
how are you doing?
I'll unmute again then. Good.
No worries, Mark. Did you have a question, or are you happy?
No, I didn't. I'm just eavesdropping.
Awesome. Glad you could join us.
And thanks
hey, Mark,
to everybody
your,
for. Sorry, Sean. Go ahead.
I was saying, hey, Mark, throw your new company website in the chat for all of us to check out, because people will think your wood tiles are pretty freaking cool. So give it a little shout.
Thanks, I will. But when they go to it, it'll still say pending, but it won't be pending for long.
I know. Good stuff, Mark. Okay, Shannon, go to more questions.
Yeah, so thanks to everybody for putting the questions in the chat, and keep them coming. We have our next one up from Lance White. Lance, are you with us? Hi.
Yes, I am. I'm still with you. Maybe old, but still with you nonetheless. Hi. I had two questions, but some of them have been answered with the lack of. I'm a structural engineer, so I view through that lens. So I looked at the block, and incidentally, I think there's a manufacturer getting started in just north of Calgary in hemp block of some kind. I mean to get by there and have a look, but I'm a couple hundred kilometers away. Anyway, that's one question, and I'd like to have somebody test the material in structures, because I use styrofoam as a structural member in a lot of applications, and it proves to be although not sustainable, it does fill the bill, and sometimes that's what you need in a project. The other question was on your last project, the multifamily in upstate New York. It was 14 families or something like that. The section showed a section of a 2x6 structural member. Well, I live in a 100-year-old house, and the whole area is 100-year-old houses, and there isn't a 2x6 construction anywhere. As I remember, I'm old enough to frame houses in 2x4, and this 2x4 framing is particularly you block it, or you're sheeting one side, but it's the structural adequacy is beyond that which was required. Now, 2x6 became the norm, and in the business, as I understand it, because of the insulation capacity, just the extra width. Well, lumber is fairly expensive these days, and if we're going to have a hemp or another kind of insulation on as the fundamental insulation, the less timber you have, the better. So I just wondered why that particular one, and maybe it just you didn't have a structural guy handy to push to say, look, that's what you need. Sorry, that's it.
Yeah, I think that's great, and you're absolutely right. Shame on us for using 2x4s if we can, or using 2x6s if we could use 2x4s. The problem is that we actually needed the extra bump in R value. The 5.5 inches of mineral wool insulation to the outside was, kind of the limit that the builder was comfortable in going in terms of fasteners. And once you go to 6 or 8 inches for mineral wool insulation, it gets a lot more complicated in terms of fastener patterns and the specifications for fasteners. And so that actually adds cost pressure upward to offset the difference in wood pricing. So yeah, I hear you about the 2x4 versus, my building here is 2x4 construction as well. It's kind of a hybrid in timber and kind of a transitional period between conventional framing and timber. But yeah, there's no reason to use 2x4 unless it's just getting into the level of insulation required.
Just as a supplementary there, I have had arguments with those that specify attachments for all manner of insulations and those that are non-structural elements, because they don't in fact hire structural engineers oftentimes to make those recommendations. And they say, well, you're just throwing shite in the wall here if that's what you're doing, guys. And structural engineers are, some of them good ones may be hard to find. I don't know. I've never looked for one, but hunt around, dig in the weeds a little bit, find somebody that's going to give you the real goods and test the damn stuff. Because I mean, to arbitrarily say that you need all of this attachment for when it's not really required, and there's lots of ways to attach. But anyway, I'll just leave it there. I've taken up enough of the time for the folks in dealing with structures.
No,
Thanks.
I think it's a great contribution, and I think we found our structural engineer, Lance.
I'm semi-retired and I have 6 grandchildren, and I'm doing small projects, and no offense intended, but I don't work for architects any longer. They just change their mind too often. And
no.
I can't deal with it.
I was with you until then.
Well, there are exceptions, I'm sure, and there are a couple in town that I do work with, but I much prefer.
We're not all bad.
No, not bad, but I prefer working with contractors. We speak the same language, and that's why I can
you know what?
talk on the phone, and we can get things done, and a photograph on site and a live conversation. We can solve so many problems with sketches and all, and it's done. And I can sit here in Edmonton and do things all over the place, or I can sit in my sailboat in the Baja and do the same thing, which is not accessible at the moment, which is a bit of a problem.
Lance, I would just like to engage the community and say that we need to engage the structural engineering community with people like yourself that are solution oriented with our passive house community, because it sounds like you're the type of person that is very much like a passive house person, that's solution oriented and goal oriented. And there are not a lot, I personally, I don't interact with them all that often on the subcontractor side, but it would be great to have a wider net of structural engineers that engage in passive house and really get into the data of it. I know Mike has a few structural engineers that come on site and that I see, but
Absolutely.
They work with you. Yeah.
Yep. Yeah. I don't make a move without my structural engineer, and I really like to have them with the builder on site. I can't tell you how many times once we all agree, we know we've got the solution, right? And we know we've got the most affordable solution. So definitely good advice.
Saves weeks of time, weeks. It's amazing the snowball effect of not having a structural engineer who's able to do that, or mechanical.
And the builder too, right? I've had a $12,000 solution turn into an $800 solution.
So true.
Just by having 3 guys in the room together, and well, I'm counting myself as one of the guys right now, but absolutely.
I'd like to circle back on James's 2x6 wall and say that 2x6 wall is used in Sean's neck of the woods by Marcel Studer, and he calls it the fat wall. So it's a 2x6 wall and then exterior rock wall, and it's one of the more simple buildable wall assemblies that are out there if you can get your layers right. So even though it might be a waste of lumber, but it's an efficient of like framing, and go from 2x4 to 2x6 is an easy upgrade for standard framers to do. And then you can let all us nerds do the airtightness and the insulation on the outside. And great point of the structural decreasing the amount of fasteners needed for those upgraded insulation products. But
one more thing too about the 2x6 walls, And 2x6s are much straighter, than 2x4s.
That's a true story. Well, it's almost the top of the hour, so I think it's time to hang tight. And James, I hope you can stick with us while we hand it off to Zach for a minute.
Thank you, Shannon. And thank you, James. This is really wonderful night tonight. I want to thank our sponsors that make everything happen for us at the Passive House Accelerator. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxtingui Architects, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsors are SIGA and Icon Windows. Our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thank you also to our patron sponsors, Aero Barrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Euroline Windows, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Tomorrow, we have a very exciting Passive House showcase with Alyssa Booker of Rogers Partners Architects. So we all know that Local Law 97 is requiring that buildings of 25,000 square feet or larger dramatically slash their greenhouse gas emissions to very low levels by 2034. So how do you do that? Alyssa is showing one really big important step here with a high performance recladding of a 20-story apartment building. So it's a great presentation about a really inspiring project that can be replicated hopefully many thousands of times in New York, because there are 50,000 buildings there that are impacted by Local Law 97. So join us tomorrow for the showcase. On the podcast, we have Jason Quinn of Sustainable Engineering joining Matthew Cutler Welsh for a great interview. Jason is actually a rocket scientist by training. He was a scientist at NASA for many years before diving into building science, and he's become a leader of building science practice and communication and advancement in New Zealand. So he's an expat, American expat in New Zealand. Great interview. Also, next week, we don't have an image for it yet, but next week at Construction Tech, we are joined by none other than Allison Bales of Energy Vanguard. So it's going to be a fantastic presentation with Allison that you won't want to miss. And finally, I want to share the FIASCon information here. It came up. This is FIAS's conference is now called FIASCon, and it will be October 12th through 15th in Tarrytown, New York. There is not a live online version. So if you want to catch this, you want to catch it in person. So please join us. I'll be there. Michael will be there. Shannon, many co-hosts and lots of people on the call right now will be in Tarrytown taking in this fantastic conference. So we hope to see you there. Thanks, everybody.